Next, in the following few examples, we're going to be using properties of cube roots. You can pause the video here and go back to chapter 6 notes to kind of refresh your memory on how to do cube roots and square roots and nth roots. But in this example, part A, cube root of negative 128, 128 or negative 128 is not a perfect cube here, right? It's not a perfect cube. So we're going to be thinking, how can I break this apart to find the greatest perfect cube factor and then simplify basically? So I am thinking to break this into 64 or negative 64 and 2. Make sure you keep the cube root. If you can't write this small, write the radical big. So negative 64 times 2. And how did I find this? I'm just going to keep on playing with numbers and multiply factors together to find the factors of negative 128. And this seems to be the greatest perfect cube factor. So then by using the property of, or product property of cube roots, I'm going to split these two into cube root of negative 64 times cube root of 2. And again, you can skip this step if you can see that already, now that you've done a few problems. Then I know that this has a perfect cube. So that would be negative 4, because negative 4 times negative 4 times negative 4 is negative 64. We don't have a cube root of 2, so we just leave that alone. And that's it. Now part B, cube root of, or take a cube root of 125 x to the 7th power. I know that this is combined with the multiplication, and I also know that I have a perfect cube of 125. So I'm going to leave that alone. Now I'm going to think about how to break this apart so that I have the factors using, or I have to have the factors using the greatest perfect cube factors. So keep 125. I know for a fact that x to the 6th power times x to the 1st power makes x to the 7th, because same base, we add the exponents. And I also know that x to the 6th has a perfect cube. So if I break everything apart, it's cube root of, again, you can skip this part, times, and cube root of x to the 6th times cube root of x to the 1st, which is x. Then I know this is 5. 5 times 5 times 5 is cube root of 125, perfect cube. Then this one also I can take out. So I have a x squared times x squared times x squared in there, because 2 plus 2 plus 2 is 6. So I have a cube root of x to the 6th is x squared. Then I do not have a perfect cube of here, so I'm going to leave that alone. Let me just rewrite that. So 5x squared cube root of x. And that's my final answer. Last two questions. Using cube roots, cube root of y over 216. Again, you can skip this step, but cube root of y over the cube root of 216. Can't do much here. Leave it as cube root of y. I know that cube root of 216 is a perfect cube, which is 6. 6 times 6 times 6. Next, we have a combination of variables and exponents and numbers. Cube root of 8x to the 4th over 27y cubed. First of all, I'm going to try to see, so this is a given step, right? Dividing the quotient apart. Cube root of 8, cube root of x to the 4th. I can break this inside somehow. Let's work on that. So cube root of 8 times cube root of x to the 4th. And notice I can break that even further. Cube root of 8, I already know the answer to. Then the bottom here is cube root of 27. And then a cube root of y. And again, you can skip this step if you would like. Cube root of 8 is a 2, because it's 2 times 2 times 2. X to the 4th, remember, you're thinking about the greatest possible cube root you can take from there, the factor. So I know that I can do cube root of x to the 3rd times x. This is basically x times x times x. And if or x times x times x times x, I'm sorry. Then if I know I can take this out, I'm going to combine and then do that, so that I can take out an x. Here, cube root of 27 is a 3. Cube root of y cubed, these two cancels each other out because y times y times y, cube root of y cubed is y. So here I'm going to do a little bit more. I'm going to do it over here. 2 times cube root of x to the cube root of x, that stays, and then we have 3y on the bottom. This also cancels each other out, so we have 2x cube root of x over 3y as our final answer.